All right, now for our example, we're going to talk about glow sticks. A glow stick, it's really two parts. You have the normal glow stick, right? This is your normal glow stick. And then inside there's this little glass tube. The one inside has one chemical, and the mixture on the outside has another chemical. So when you take that glass, you snap it and crack it, and you crack the glass that's on the inside. This chemical comes out and it leaks into the body of this tube, and it basically mixes with the other molecule that's inside of it. All right? This reaction produces light, and it's beautiful. Now, if you're like me, when I was little, I would snap it and crack it and then shake it. Shake it really hard, because the harder I shook it, the brighter it got faster. And you know, the light in the glow stick, it doesn't last forever. I mean, eventually it starts to, it starts to slow. The collisions inside of that little necklace or bracelet or whatever it is, they start to occur, and then they occur more often, and then the reaction is proceeding to the end because a lot of collisions have taken place, and the molecules are basically, being used up in one direction. So it doesn't last forever. And it's not always the same brightness. I don't know if you know this, but at one point there's a low level of light, and then you can increase its brightness by shaking it. When I was little, in order to make its brightness last as long as I could, I would put it in the freezer, just because I thought that would make it last longer. The brightness changes over time. It's quite disappointing if you have 3 little children and you buy them all glow sticks at the park or something like that. They wake up in the morning and they're no longer glowing, because the collisions have occurred, and the energy required for the collisions to occur has basically run out. And inside of that little glow stick, Clyde and Ita in the beginning are just colliding like crazy, and then eventually it slows down and it no longer occurs. Okay, so let's just do a hypothesis here. Let's just say I take my glow sticks and I want to perform a test. I have one glow stick at the room temperature, right? So this is going to be our room. I put another one in hot water, and I put another one in the freezer. What essentially is going to happen to these glow sticks? Will one get colder? Perhaps. But we're really talking about the light here. The light that is provided by the collision of the molecules inside of that little container. Why do we use one at room temperature? Well, the one at room temperature is what we call our control. Our control is used to see if there is even a difference between the hot and the cold one. In the hot one, I am going to increase the kinetic energy and therefore increase the collisions in the container. In the cold one, I've decreased the temperature, so I decrease the kinetic energy, and so I slow the amount of collisions in the container. And this is actually something that potentially that we could measure. So why do particles have to hit with a certain amount of energy anyway? Like, what is so special about Collide and Ida colliding? Like, why do they need so much energy? Why doesn't it just happen on its own? And that's because molecules have bonds between them. Maybe you saw something like this a long time ago. Like, well, this is just a sugar, so let's just draw a sugar right here. This is a sugar, so it's very, very sweet. And in between these carbons and hydrogens are bonds. And Clyde is going to need a lot of energy to smack in there and break those bonds. So they require a certain amount of energy, or a high energy, in order to crash into these bonds and cause them to break.